Now let's try another example with finding the volume of a solid using the disk method. Find the volume of the solid when the region bounded by y is equal to x squared, x equals 0, and y equals 5 is rotated about the y-axis. The first step in finding the volume of a solid of revolution is to sketch a graph of f of x. It's y equals x squared, or the parent parabola function. The next step is to determine what's the axis of revolution. Well, it tells us the y-axis. So that means we are going to revolve this function about this axis. And the next step is to draw a representative disk. So first we could do the top. You can see how it looks open that way. And then do another circle about halfway down and label it with our radius that we have there. Step number 4 is to then set up the integral. Remember, this curve is rotating around the y-axis, so it needs to be put in terms of y. And right now we have y is equal to x squared. It's not in terms of y. If we were to solve this for x, to put it in terms of y, we would get that x is equal to plus or minus the square root of y. So then if we substitute our f of y in and square it, we'll have that the volume is equal to pi times the integral from 0 to 5 of the square root of y quantity squared dy. Now, you can put the plus or minus in there, or you can leave it out. And the reason we could leave it out if we wanted to is because once we square the square root of y, the square root's going to go away. So we can rewrite this as pi times the integral from 0 to 5 of just y dy. And step number 5 is to integrate and evaluate. So if we integrate y with respect to y, we'll end up getting y to the second over 2. We still have the pi out in front, but then we're going to evaluate this integral y squared over 2 from 0 to 5. When we do that, we'll have pi times 5 squared is 25 over 2 minus 0 squared over 2 is 0. So we end up getting pi times 25 halves, or 25 pi over 2 as our final answer.